question. A current of 20 amperes is passed for 30 minutes during the electrolysis of gold 3 tetrasulfate 6. Calculate the mass of gold deposited at the cathode. The atomic mass of gold is 197 and 1 Faraday is 96,500 coulombs per mole. So to solve this question, solution. Okay, so to solve this question, we'll firstly write out the given parameters. Current I is equal to 20 amperes and the time taken to pass the current T is equal to 30 minutes. Now usually we are going to convert this time to seconds, and we know that 60 seconds make 1 minute, so we are going to do 30 minutes times 60 seconds, and that will give us 1800 seconds. So now that we've converted the time to seconds, we are going to calculate the quantity of electricity passed, Q. So to calculate the quantity of electricity passed is equal to current times time. So Q will now be equal to 20 times 1800. Q is equal to, let's multiply 20 by 1800, and that will be 36,000 coulombs. 36,000 coulombs. Now we know that 36,000 coulombs of electricity was passed to during the electrolysis of gold 3 tetrasulfate 6. Now how do we calculate the mass of gold deposited by these 36,000 coulombs of electricity? Now we have to set up this reduction equation, the reduction equation for gold, to know the amount of electricity required to deposit 1 mole of gold. Then we now use stoichiometry to determine the amount of electricity deposited by 36,000 coulombs. Let's do that. We have gold 3, that's Au3 plus gold 3. The question told us we have gold 3, so that's Au3 plus, and this gold 3 will be deposited, 1 mole of gold will be deposited by 3 moles of electrons, and that will be Au solid. That means we require 3 moles of electron to deposit 1 mole of gold. If we have a particular ion that carries, let's say 2 plus, then we will require 2 moles of electron to deposit 1 mole of that ion. Now we have 3 moles of electrons deposit 1 mole of gold, so we can write 3 moles of electron deposited 1 mole of gold, and we know that 1 mole of gold is 197 grams of gold, so we can say that 3 moles of electrons deposited 197 grams of gold, and also 3 moles of electrons is equivalent to 3 Faradays of electrons, so we can say 3 Faradays of electrons deposited 197 grams of gold. Sorry, I mean 3 Faradays of electricity. Okay, so now we can say that 3 Faraday of electricity deposited 197 grams of gold. Now what is the equivalent of 3 Faraday of electricity in coulombs? We know that 1 Faraday of electricity is 96,500 coulombs per mole, so which means that 3 times 96,500 coulombs of electricity deposited 197 grams of gold. Are you following? We just multiply 96,500, which is equivalent to 1 Faraday. We multiply it by these 3 to know the quantity of electricity in coulomb that deposited 1 mole of gold, which is 197 grams of gold. Now we want to calculate how many grams of gold will be deposited by these 36,000 coulombs of gold of electricity. So which means that 36,000 coulombs of electricity will be deposited by 36,000 coulomb of electricity will deposit, let's say, X grams of gold. Now we have to cross multiply. We can set up an algebraic equation and say that 3 times 96,500 coulomb is equal to 197 gram, then divided by 36,000 divided by X. We just set up an algebraic equation, then cross multiply. We are looking for X, then we are going to have X is equal to 197 times 36,000 divided by 3 times 96,500, and this X will now be equal to, if we use the calculator, 197 times 36,000 divided by 3 times 96,500, and that will be equal to 24.5 grams of gold. 24.5 grams of gold. So which means that 36,000 coulombs of electricity will deposit 24.5 grams of gold. Thank you.